Hi, so in this first short video, we're just going to look at something that you're going to need when you're trying to draw a mechanism for a fragmentation reaction, and it involves homolytic reactions. Like is shown at the top here, what you've seen so far in Chem 250, Chem 251 are heterolytic reactions. These reactions are characterized like what is written here, and that these reactions involve the simultaneous movement of two electrons at a time. So if we were to draw the mechanism of this acid-base reaction, you would start the arrow on, the lone pair end up attacking the hydrogen, and then you take the two electrons from the bond and they move at the same time onto the Y atom. So that in these reactions, a proton, or H+, is exchanged between two species. Now, the type of reactions that we're going to see in fragmentation reactions involve radicals. So there's going to be the movement of one electron at a time. These are called homolytic reactions. When we see homolytic reactions, we're going to use a different type of arrow that not only show the movement of one electron, but we're going to use half-headed arrows. Another characteristic of these mechanisms will be that the arrow ends up where the electron is found at the end of the reaction. You'll see what we mean by that. And then you'll see that when we draw these reactions, if there's a bond that is broken, we have to show that the two electrons of the bond move in opposite directions. Overall, whereas in the first type of reaction, a proton, or H+, was exchanged between the two species, in the examples that we're going to see here where there are hydrogen atom abstractions, it's a hydrogen atom, or H dot, that is exchanged between the two species. So if we look at this first reaction here, where you can see that this hydrogen here is exchanged between X and Y, if we have to draw a mechanism where X is a radical here, so only one electron here, if we have to draw the mechanism for this hydrogen atom abstraction, we're going to use a half-headed arrow, and then this half-headed arrow is going to start on the electron and end up where the electrons are going to end up in the end, which is in the XH bond. So this arrow ends up right where the XH bond is going to be. And then in this reaction, the YH bond is broken, so one of these electrons is going to end up in the bond, and one of the electrons moves on in the opposite direction onto the Y atom. This scheme will give you the formation of the bond here and create a new radical, Y radical. Now, when we draw these reactions with these half-headed arrows, the direction of the half head is not very important. So you could have drawn this mechanism, let's say like this, and maybe something like this, and that's all good. Doesn't matter really in which direction it is, or you can draw something like this, have one come from the bottom, have one come from the top. That doesn't matter. But what you see is that the main difference from what's at the bottom here and what's at the top is that we were not going to draw a mechanism like this where we show one electron attacking one atom here. Like we said here, we show that the electrons end up, that the arrows end up where the electrons end up, which is the XH bond. So we're not going to be using this kind of arrow, so this is not good here.